And we're live. Check, check, 1, 2, check. All right, we are all set. Welcome to the stream, everyone. Today we will be doing an homage to Space Invaders. We've been working through a CodeCademy course on JavaScript and Phaser, and last time we worked through a choose your own adventure game and learned how to create different text boxes and switch different pages as we clicked on the text boxes. And today we will be working with our little Cody character and these bugs up here to create what you see on screen. So this is a finished version of what we'll be doing today. Where it's a little shooter like this that you control with the arrow keys and then the space bar to shoot those little pellets out. All right, so first of all, let me reset this, and then we'll be building up this code from scratch. And once we do that, we will be ready to go with our bug invaders. If you want to watch the rest of this tutorial series, although it's like tutorial slash playthrough because I'm learning it myself too, but if you want to see the rest of it, you can go to YouTube, same name, Noctophonics, and watch along from the very beginning. Right now we are diving into some of the phaser physics in this lesson, and we'll be working out what we learned in the last one yesterday. So anyway, we will get right into it. Bug invaders. In this project, we're going to take the skills we've learned from our phaser physics lesson and create our own version of Space Invaders. Since this game uses some of the mechanisms of the one we created in the phaser physics lesson, we're porting over some of our previous code and building on top of it. So before starting, make sure to check over the comments and get an understanding of what's already in the game. Okay, so, and then it says to save your code in order to see the changes reflected in the browser. Yes, must always do that when we are making any changes. So let's look at the game file. It looks like there's only 2 files in this one. There's no like start scene or end scene. It's just the game and then the HTML index to set up the canvas for us. So we'll take a look at what's inside of the game.js first. They've got all their preload images set for us. Looks like there are 3 different bugs, platform object and Cody. I think, can you control Cody at this point? You can. Okay, so this is sort of what we did last time. We created, we set the world bounds for Cody so he can't fly off of the screen. And then we also gave him a collider to meet with the platform, that little teal box that you see underneath there. We set the collider up for that so that when he's falling or whenever he's affected by gravity, he'll stop at that platform. So when that collision happens, then he doesn't fall through it. Yeah, I don't think anything else. Yeah, there's no other functionality with the arrows or the space yet, but you can move them around. So that is the preload section. Then they've set up some helper functions for us. Looks like some of the coordinate systems that we were seeing last time, just to set up the bug array. We'll get into that in a little bit. Also, this sort method is going to be very important. We don't have to do anything with it. They've already set it up for us, but understanding that is pretty important for how they behave. They have a helper function of the number of total enemies. Okay, looks like they're just setting up how many are in the array. They have a game state object. As always, we need that set up or initialized at first. And then they have the create function here. So within the create function, they are setting the game state to active, just basically enabling all of the physics that we have. And then they're listening for a pointer up. There's just a click. If the game state is false, then it restarts the scene. Basically just like an end condition. If you lose or if you win, then you click the screen to restart it. That I'm most likely going to change. I did change it in the finished example there to space. I like that instead for games like this where you're just working with the keyboard. And if it's just like a quick arcade game, you don't really want to reach over and click the mouse to restart. It's easier just to press the spacebar or press enter and keep your hands on the keyboard to play another round. So then they set up the platform object. Again, like from last time, we learned about groups and static groups. Static groups can be collided with, but they are not affected by gravity. So they won't fall at all. They'll remain stationary unless something else collides with it, and you've set up like gravity to affect them at that point. Like say like blocks in Mario that once you step on them, they start falling. They are a static group, but then once that collider happens for a certain amount of time, then they fall and they are affected by gravity. They wouldn't change to be a group; they would just be affected by that collider, and that way you would affect them with gravity. And then group is basically it's this but gravity also. So like with the bugs, they'll be affected. Actually, I don't think the bugs in this one will be affected by gravity. I think it was just the one where the game where they were falling we made yesterday. Okay, so we have the platforms create. We set that up to a little bit smaller than what its original size was, whatever the PNG they gave for it. They set up the text that we see underneath there for the bugs. I set it equal to 24. And then they added the Cody sprite. They made it so that he doesn't escape the world. So this sets the collide world bounds so that if you reach the end of the screen, he won't go off screen. An easy way to test this is like when you're first starting and your character is affected by gravity. If he falls through the floor, you know that these aren't set to true. So you want to set that to true on the player itself, whatever that sprite is. And then we have a couple colliders, or just one, I guess, just for the game state and platforms. When that happens, then, I guess that's just the one line. So there's just a collider between Cody and the platform, so that he won't fall through it. And then they've set up the cursors for us. This is just initializing like that we can use the arrow keys in space. It's like the arrow keys, shift, and space are the 6 that are automatically in this cursor key set. And then we have the update function. This one, let's see. So it's listening for a few. Yeah, this is where it's listening for the left and right arrows. And when we press those, then it's setting the player's velocity to either a positive or negative X value. So just sideways on the screen. And a quick distinction for you here is like if you set the velocity to this and you don't reset it, if we just delete this last line here in the else statement, if you don't reset that, then as you press it, he'll just continue on. Even if you're not holding it down, he'll just continue on the screen until he reaches the end point, or until he goes out of sight. So what's happening is that the velocity is really being just set to one number, and it's not listening again for if you lift your finger off of the key. It's just if it's down, it sets to that, and then it needs another sort of input, or in this case an else condition, that sets it back to 0. So with this, it's saying that if the right arrow is not down and if the left arrow is not down, then set the velocity to 0. So that's the default that they set there. Done with that else statement. You can also do it where, like in the Business Bob one, we set it to be like his X coordinate subtracted, or minus whatever, a certain number of pixels, and that way it's happening every frame versus just set as once and then reset. This might be a little bit better if you're doing like a lot of conditions like this, just like on memory or processing, where you just set it and you're not checking it or not updating it every frame. You're just setting it to that and then resetting it. All right, so let's see. So we looked at that. I think the rest is just the config file. We looked at the physics of this before. This is setting up the default stage for us. We're in arcade mode, which basically just gives us like a set of properties we can adjust. We have gravity, and we've enabled the body to be true. Actually, they haven't gone over the enable body yet. Last time we saw that we could do a debug. So if we do like debug equals true, then when we move, we can see how Cody is affected by our keyboard inputs. And so right now it's equal on either side, and his velocity is the same. Once we stop pressing a left or right arrow, then you can see that that green line disappears, showing that he has no velocity. And then you can also see his little hitbox there, that pink box around him, to wherever he can collide with things, just like the bottom or the top of this platform. He is colliding with that. Okay, so we'll go ahead and delete that. I'm not sure what the enable body does. This might just be so that things can collide. We didn't really see that the last time. I don't know why they need to enable that here. But if they tell us, we'll know. All right, so we looked over the code there. Conditional in place for when spacebar is pressed. Oh, I see. Yeah, so they do have one set up for the space. But there's nothing within that code block. So we're gonna probably start right here. In Bug Invader, there are 3 rows and 8 columns of enemies. In create, let's create these enemies. Call this physics add group and assign it to gamestate.enemies. We'll use gamestate.enemies to create our bugs. Okay, so we'll go ahead and do that in the create. So right above the update function above this brace here, we're gonna add our code below. Line 54, this dot physics dot add dot group, and we're going to assign this to gamestate.enemies. Gamestate.enemies, like so. Okay, and that'll set up the group for the enemies, but we haven't assigned that to anything besides the property variable, or the property. All right, so inside of this, we're going to use, or no, not inside of this, outside of this, we're going to use a for loop to create our rows of enemies. So there will be 2 for loops here, a nested one inside of the other. For the first one, we're going to set it to be adjusting the Y value of the enemies. So we'll start with that. So for parentheses, then we can just make our variable equal I equals 0, or I guess we can just literally call this the Y val. So Y val equals 0. This has to be declared as a variable first, so let Y val equal 0. I think they're separated by semicolons here for the for loop. It continues running for as long as Y val is less than 4. Okay, so Y val is less than 4. Okay, and then increase Y val by 1 for every iteration. So just put Y val and then plus plus. Okay. Inside the for loop, we're going to create another for loop to create the columns of enemies. So these set up the rows, and we will work on the X values to set up the columns. So there will be 4 rows of enemies stacked on top of one another, and then looks like there will be 9 columns. So let's see, we've got, hey, how's it going? Welcome in. Let xval, wait, I did not spell that correctly. Let's try xval equals 0. For this one, we're going to have xval it's going to run unless it's greater than or equal to 9. So while it's less than 9, xval increments. Okay, step 5. Inside the nested for loop, call gamestate.enemies.create. The arguments in the following order: 50 times x, 50 times y, and then bug. The first 2 arguments will provide adequate spacing between the bugs. Save your code to see the bugs, your created bugs falling down. Okay, so within this, we'll call the enemies create function that we made with the grouping. So GameState.enemies equals, or no, we don't have to equal it to anything. We're going to do a create method on it. So create, and for each of these we want it to be separated by 50 pixels, 50 times xval, 50 times yval, and then bug1, and this will access that sprite. Okay, let's see what that does. All right, well, we've got our bugs, and they do appear. Oh, let me reset that. Do appear at the top of the screen, and then they are affected by gravity. Let's see, it looks like they're appearing, like they're spawning, the first row is spawning too far to the left, like we set their origin to 0, but their origin is in their center. So we might have to adjust that later, but we'll see what they walk us through here. Okay, so we don't want our bugs to fall down immediately, and we'll get to making the bugs move later. For now, let's make sure they stay up and scale them down a little. Okay, so let's chain set scale to the create method. Okay, let's do that then. So we're gonna say, this is like what we did with the characters in the fantasy game. We did a set scale to make them a little bit smaller. Set scale to 0.6. And I think that's, oh, they're also going to counteract gravity by set gravity. And this doesn't set it for the whole like game, it just sets it for whatever you're working with right there. So you're setting an individual gravity, and in this case it's on the y value, the y axis, so negative 200 to counteract that. And I think let's see, set scale, set gravity. There we go. Just need to move that over. Okay, so now we have our bugs populating. They're a little bit smaller. They're still spawning too far to the left and too far up. We'll adjust that in a bit. But this is a step in the right direction because now they're not falling. They're not affected by gravity. We want them to kind of just like jerk over and down, like the Space Invaders game. Okay, let me go over what we had before for the coordinates. Xval minus that, yeah, all that's working just fine. 50 times x, 50 times y, bug1. Yval equals 0, xval equals 0. Oh, that's what, okay, so xval starts at 1, it doesn't start at, there we go, yeah. I had that set to 0, so it was putting the first column's origin like on the left edge, set to the bug's origin, and we want that to be at least 1, so that 1 times 50 would be 50 pixels over from the left edge. Okay, so with our bugs in place, let's create some pellets that the bugs try to drop on Cody. Declare a pellets variable and instantiate it with this physics add group. Pellets is the group object we'll use to create individual pellets. All right, cool. So outside of our for loop here, we're going to declare another variable and just call it pellets. This is going to be a physics group that is affected by gravity. Also, I don't know why, I'm curious why they didn't just create the bugs one as a static group that wouldn't be affected by gravity, right? That you could still change its position, but it just wouldn't be affected by gravity. It was probably so that they could show us the set gravity method, which is really handy. Okay, so this add group for the pellets. And that's it for this line. In create, declare a gen pellet function. Inside gen pellet, declare a variable random bug and assign it to that. So phaser utilities array, get random with game state. Okay, let's type all this out and then let's break it down. So in here we want to create a new function. Just going to do that with a simple function declaration gen pellet with a variable random bug. So you don't use that random bug as a parameter, you actually declare it inside of the function. So, and this, I'm gonna go ahead and make this a let random bug. Although I guess it could be constant because it's going to set a random bug every time you run the function. Let random bug, and then it's going to be equal to phaser dot utils dot array dot get random, and then we have within this an argument of game state dot enemies get children. Okay. So, and what this does, the get random takes an array and selects a random element in that array. Okay, so then the array that it's selecting is within those parentheses. So our game state dot enemies array. The get children is called on a group object and returns an array of the sprites belonging to the group. Okay, so the group object that we have set so far is enemies, and then the get children is to say, treat that as an array and grab it so that we can use it here, so we can reference it there. Yeah. And I think it's good that we set this. I'm not sure if it would mess up the order, or if we change the order, if we move the function above the for loop, or even above the group declaration, if it would throw an error because the array is not set. But I think this would just return as like 0, as nothing's there. So it would just be an empty array, which would still be fine. You just wouldn't have any functionality with it. But anyway, so we set up our enemies array first, and now we're accessing it through the get children. Okay. Step 9. Still inside gen pellet under random bug, call pellets.create random bug x, random bug y, and bug pellet. Okay. So let's call our gen pellet function, or no, not call it. We're going to call pellets.create. And random bug's x value, that needs to be, the B there needs to be capitalized, and then random bug y, random bug.y, and bug pellet. Okay. Soon we'll use gen pellet to drop pellets from a randomly selected bug. Cute evil laughter. Okay, cool. So that's accessing the group object here that we set up, and then we will, yeah, so get random bug. So this is going to select a random array of the enemies and then generate a pellet from that point. So wherever the bug is, it's going to populate a pellet and have it drop. Okay, so let's see what happens right now. I don't know if it's going to be, because we haven't called the function yet, it's not going to do anything. We've just set up the function. All right, so while our game is active, let's make the bugs continuously create pellets and use the gamestate.pellets loop to keep track of this loop. So in create, assign that value, the value of calling this time.add event, then pass in the following object as an argument. Okay, so they're setting up a timed loop for this function to run. So we're going to say, we're going to set up another variable. I guess this still needs to be within the create function. So right here, gamestate.pellets loop. And we're going to assign this the value of, well, a loop. So this .time.add event, and then pass in that object. So we need to create an object, set the delay to 300 milliseconds, That'll be how fast the pellets drop. The callback function is going to be the one that we created before, so it's going to be gen pellet. Then the callback scope is going to be this scene. And then the loop is going to be true unless we break it. All right, so now, there we go. If we restart that, we save that code, we can see our pellets dropping from random bugs. Cool. Yeah, so this runs through, it says, okay, run gen pellet every 300 milliseconds, and what that does, like we explained before, pops out a pellet from a random bug. Cool, cool. Now, if we move into those, nothing happens, right? There's no risk with Cody moving around. He's just getting dropped on by some bugs. All right, step 11. The pellets aren't interacting with anything right now, so let's change that by adding a collider between pellets and platforms. When the pellet hits the ground platform, the pellet should be removed or destroyed. So call this physics.addCollider with the following arguments, pellets and platforms, and a callback function to remove the pellet when it hits the ground platform. All right. Simple as that. So let's set up our collider here. This physics.add.collider. Following arguments of pellet and platforms. And then within the function here, I forget, is it, we can do an arrow function and I think that would be fine. We can also just do an anonymous one function. And we could set in there like pellet or something, but that's unnecessary. We can just put in here pellets, or pellet.destroy. So yeah, it's going to take the pellets, and I think, oh, this needs to be plural because they set it up as a group object. Same thing with platforms. They set that up as like a plural object, even though there's just one of them. And then we want to destroy the pellets wherever that is. Of course, within the function itself, I think, yeah, you need to set a parameter here of something. So let's just call it pellet. And then this way, when it has, like it has the scope of that. It doesn't have the scope of these two. It can't see what those are. It can only see what's inside of these parentheses. So now it should destroy it and not freeze the game. Yeah, there we go. So it collides with the platform and destroys the pellets. Cool, cool. Scope, when we first learned about scope, it felt like such a simple thing, but it's so important with things like this, where to know like what functions have what scope. I mean, yeah, they have function scope and they can access global variables, but just to remember that even within like a larger method, each function needs to have its own like parameters to reference. Okay, so step 12, there have to be consequences if a pellet hits Cody. To set up this interaction, create another collider between pellets and player. Okay, and then an empty arrow function that we'll add to later. All right, so let's add this in, our collider for Cody. This.physics.add.collider. It's going to be between pellets and GameState.player. Okay, and then the function here is just going to be an empty arrow function. Whoops. Like so, and then we'll add to it in step 13. Step 13. After a pellet hits Cody, it's game over. Therefore, we want the callback in the collider to do a few things for us that would indicate the game is actually over. Inside the anonymous arrow function you created, do not assign any parameters. Set GameState active to false, destroy the pellets loop, pause the physics, and add a text to tell the players that the game is over. Okay, let's go ahead and do that. This one, So we don't need any parameters for this. We're going to set the game state active to false, which this basically means that the player can't move anymore. You don't have any keyboard inputs unless it's specifically stated like within that collider or the update function. I guess this is only happening if the game state is active. So anything, any keyboard input when the game state is active would be negated by this. So we won't have any keyboard inputs for Cody as once the pellet collides with him. Okay, so then we need to pause the game's physics. So this .physics.pause, and this would make it so that the bugs aren't moving anymore and everything freezes. So the pellets will be stuck in midair and the bugs will too. So this .physics.pause. And lastly, we'll add text to tell the players the game is over. We're going to assign this to GameState just end text. And you can name that whatever you'd like. We're just creating a new property to store the text that we're putting on screen. So GameState.endText, I think, yeah, that should be fine. This .add.text, let's do 180 and 200 or something. And then do just the text of game over. All right, and then the style, I don't know. Let's see what the style they had was for the score and just copy that over. So they have font size of 15 and fill of black. That's easy enough to do. I'll go ahead and recreate that here so we can get into good practice of typing that out. So it's an object that has properties within it. Two properties in this case we want to change or want to set is the font size. This has to be a string, and then you put in whatever size and px for pixels. And then the second property within this is fill, is the color. This is going to be set to just a string of zeros for the hex code since it's just black. But in order to initiate this, we have to put in a string of this with a hashtag. So a string hashtag 6 zeros. And then I broke something. All right, let's see what is off here. Pellets GameState.player. The collider looks fine. GameState.active. It might be this. I might have the syntax wrong for the pause. Yeah, there's a colon there instead of a semicolon. There we go. Now when a pellet hits Cody, the game is over, and we get a nice little indication text that pops up there that says the game is over. We can go ahead and move that down to like 300. See where that is. Okay, maybe 250. Set that there. And then we'll add underneath the game over text that tells you to press a certain button to restart it. Also, one thing I've noticed, like, semicolons are good practice anyway, but for the text specifically, if you start another variable with this add text, it might think that you're just like continuing the line, so I always put a semicolon after the text declarations there. So this isn't in the instructions, but this is what I'm adding because I think they tell us to do it later. I'm just going to do it in this step. Add like text that says click to restart or press space to restart. We'll eventually change it to space, but for right now it's a click. So just call this like restart text or something like that. Like, yeah, just restart text. So this is going to equal this.add.text. It's going to be right underneath the game over. So maybe put it at 150 and 280. And because this text is longer, we want it to start at a lower x value. So this would be like press or click to restart. Click to restart. All right, let's see how that works. This needs to also have the same font and fill. So we'll copy that over. You could also put that into a global object and then just put, or a global variable, and then just put the variable in as the style, and that would do just fine. In the long run, that's usually better practice so that you're not typing this out a bunch of times, but for now, we're not doing too much text on screen. So we'll keep it like that, see what happens when we get hit. Hey, there we go. Okay, click to restart. Sweet, and their click does work. They already programmed that in. Sweet. Okay, so next we will be firing back. So let's give Cody the ability to fire back. In create a group object using this physics add group and assign it to game state bug repellent. Okay. So underneath our collider here, we're going to add a group. This .physics.add.group. And we're going to assign it to GameState.bugRepellent. So make that a variable, GameState, or no, we don't need to do that. We're referencing a property. So GameState.bugRepellent. Set that to the physics group. And then in update, locate the if statement that has the condition for the space, which is this. So a phaser input keyboard just down. This is basically sensing whatever key that you're about to say is pressed. GameState.cursors.space. This is like another way of listening for it. Like the other way is just to do GameState.cursors with the is down at the end. But this way, it's like, I'm kind of spitballing here, but it's kind of like it's just looking for the press and that's it. It just runs it once, runs the code once, and that's it. These ones, like we saw before, it'll press it, but then it sets something to a value and it continues on unless there's a condition to stop that. That's my understanding so far. It might be completely wrong, but that's why they have a separate way to like listen for that input. Okay, so inside of this, we need to call the bug repellent object we created and create it. And we want to create it where Cody is, so where the player is. So we're going to do GameState.bugRepellent.create. This is going to have the arguments of GameState.player X and GameState.player Y. And then it's going to produce the bug repellent sprite from Cody. All right, so let's go ahead and save that code and press the spacebar and see what happens. Oh, look at that. We can shoot pellets, but they drop. He's just like, he's just dropping pellets. Okay. Yeah, so it says save your code and see Cody send repellent downward. Don't worry, we'll fix this in the next step. All right, so now we need to chain our set gravity function, -400. So we're counteracting gravity, which is set to 200 within the config object. Now we're going to offset that and then basically negate it completely. So we're going to be sending it upward at a rate of 200 pixels a second. So 200 is going to be within the set gravity, or sorry, -400. Set gravity. And we can just string this along with the create method. So dot set gravity, it's of y. Make sure to put that y at the end, and then -400. Okay, now let's see. There we go. Now we can send pellets upward. And whenever we press the spacebar, no matter how many times we press it, it will always create a pellet and send it flying towards the bugs. Now the only problem with this is that the bugs do not have a collider set with Cody's repellent. So now we're going to add a collider between those groups. Okay, that's like the winning condition. Let's add something to, oh, we're still in the create method here. We want to, or the create function. We want to go back up to our, sorry, we were in the update function. We want to go back up to our create function. All right, so we're gonna have a collider set up, this.physics.add.collider. This is going to be set, going to see the interaction between GameState.enemies and GameState.bugRepellent. All right. So then we're going to add an anonymous callback function that has two parameters, bug and repellent. So within our collider, we're going to just declare a function. This is going to have a bug parameter and a repellent parameter. And so what these do, again, these are, you could literally name these banana and strawberry and have it be, have it still affect it the same as long as you reference those same names within the function. What these are doing is basically saying, all right, whatever the first element is within the collider, right? Whatever the second element is within the collider. So if you flip these and you put repellent in the first place and bug in the second place, repellent would be acting as the bugs and bugs would be acting as the repellent. So these words specifically don't really matter, but the order in which they appear does. So with that, we want to destroy the bugs. So we need to call bug.destroy. All right, and then we also want to destroy the repellent. So repellent.destroy. There we go. And then change the text of the score to show how many bugs are left on screen. So with this, you can use the number of total enemies function to return the number of bugs left. So that was one of the helper functions we saw at the beginning. You use a template, you can use a template, literal, like bugs left, number of total enemies. Save your code and test how the repellent interacts with the bugs. All right, so first things first, we need to say that we're resetting the score text. So score text, GameState.scoreText.setText. And then for the set text, you don't need to re-input like the coordinates or the font style. All you need to change is the text. So we're going to say, oh yeah, this needs to be backticks instead of quotation marks because we're going to be putting in a template literal. Fancy fancy for putting in a variable inside of a string. So $sign and curly braces, and then use that helper function they gave us, num of total enemies. And that should do it for that code block. Let's see if the collider with the bugs is working. We gotta actually hit one first. Hey, there we go. So now as we go, move along and shoot our repellent, get rid of those nasty bugs. Cool. Okay. Step 19. Now when there are no more bugs, then the player wins. Instead of update inside of the if statement that checks if the game is active, nest an if statement that checks if the total number of enemies is 0. Also, as you can see, I didn't mention it before, but our score is updating, or at least in this case, it's not exactly a score, it's just like the remainder of enemies that is updating when we destroy them. Nothing happens when we reach 0 at the moment. Okay, so inside of this, we want to find this if statement. So just like the first one that you see, inside of the update function. And let's see, where does that end? Is that here? Yeah, that's down here. So line 115 about. We want number of bugs left in the game. So we want it to check to see if the number of total enemies equals 0. And this, I'll just go ahead and go back up to the top to show you. The number of total enemies function basically just gets the array length of the enemies that we have currently. And then if we're destroying enemies, then it takes that index and removes it from the array, or the element at that index point and removes it. Get children is how you get an array from a group object. So our enemies is our group object, then we get the array from that, and then we finally access its length property, and then it just returns the number. So this is just like a check on that array. So we want to use that at the bottom here in the update function. So if num of total enemies is equal to 0, then okay, so then inside of it they show us in the next step. We want to set the game state to false. Game state dot active equals false. This removes all of our keyboard inputs. And then you want to pause the physics. So this dot physics dot pause. Oh, semicolon there, and then add text to tell your players that they've won. So this will be game state dot win text. This will be set equal to this, add text. And we'll go ahead and set it the same place that we had our game over text, so 180 and 250. This is going to say, you win! Woohoo! And then, yeah, I'll just add in our font that we had before. I'm also going to copy the restart text because that's going to be the same underneath. And then copy this font, the style of the text over. Okay. All right, so now let's see if we can defeat all these bugs without getting blasted by their pellets, what the game tells us. And then we'll add in the movement. We'll add in the movement to make it like Space Invaders and make it a little more challenging than this. Although, as you can see, so the way that we set the pellets, now it's like super difficult to get the last few bugs because they're all coming from the same column. So let me restart that and then just try to do it more sporadically. But so the difficulty increases with the fewer bugs, which is kind of cool. Kind of like that idea. But yeah, that's just because we set the delay on that to be 300 milliseconds. So no matter how many bugs there are, it will always produce a pellet from one of them in that time. Okay, and then let me see if I can blast these last couple, see what the game tells us. I could also, when you're testing it, you could just also disable the collider. Wait a second, that wasn't random. You see that? It like looped the function, but then it was only doing it half and half. That was weird between the last two. Okay, let me see if I can time this. Go. Oh no, I was too slow. Okay, we're just gonna disable the collider with the pellets and Cody. And let's see, so we got this one. So we're gonna comment this out just to check the end text to make sure that it's telling us that we won. All right. Now if we hit the pellets, nothing should happen, yeah. It's interesting. Now I'm thinking of like adding a power up to Cody and giving him like invincibility for a second. There we go. Okay, so now we have our win text, you win, and then just whatever we put under for our input to restart the game. Click it, and nothing happens. So, we need to add in, let's see, so click to restart. Like when the game state is false, we want it to be able to still click to go through, which it is doing that when we lose. So I'm not sure why it's not doing that when we win. So it's saying, yeah, this input on pointer up, if the game state active is false, then you restart the scene, but that's not working, even though the game state is set to false. Knock on wood. Let me check that again down here. Game state.active equals false. I don't know if it's said to do this within the update function. Maybe we just need to add in that same listener at the bottom, but I don't think so. That sounds redundant. Game state.active equals false. Let me check on this. Let me just search that again and find it here. If the game state.active, oh wait a second, are we, this is outside of the if condition, right? No, it's not, that's why. So, oh no, it does say to put it there though. You want to nest an if statement that checks the number of enemies as 0. Okay. So we've done that here. Maybe we need a semicolon there or something inside of the if statement. So the game state is false, then if it is, it should allow the pointer up. I noticed that they didn't have us like, well, we'll continue on. This won't limit us from finishing the rest of it. But we'll come back to this issue. I think we might need to add it underneath this and just put in like a pointer up listener within the update section or something like that. Like if the game state is false. But yeah, I don't know why it's not looping back and just saying like, oh, okay, so now that it is false, then you should restart it. Oh, wait a second, did I set it to, no, that's the correct way to say that. Physics pause, I don't know, we'll come back to it. We'll loop back around. But let's move on to moving the bugs. I'll go ahead and reset this. And also enable our collider again with the pellets and Cody. And add some movement to the bugs. So give game state an enemy velocity property with a value of 1. Okay, game state was all the way at the top here below the preload. This is going to have an enemy velocity property. Velocity equal to 1. And then inside of update, add an else statement to the if statement that checks the total number of enemies. Okay, so back down to where we just were here. We're going to add an if or an else statement here. And we're going to call the array. So we're going to call the game state dot enemies dot get children. to the array of bug sprites, then call for each iterator and create a callback that increases each element's X property by the velocity. So strung along with this is the for each. So for each element within that array, and within this, I think we need to set it as, I forget the syntax for the for each. I think it's like this, where you put in like an object or whatever you want inside, or you don't even need, I don't even think you need the braces for the for each. It's just considered a code block on its own. Create a callback that increases each element's X property by game state enemy velocity. Okay. Oh, wait a second. You need a nested set of parentheses if you're going to have it access the elements within the array. We can just call this bug, since we know that that's what it's accessing. Bug. Create our arrow function. Inside of this, we increase it by enemy velocity. To access that, though, all we need to do is bug.x, because bug will be an object within the array. So for every bug, for its x value, increase it by velocity. So plus equals game state dot enemy velocity. And I'm going to put this as, I'm going to add one thing here. I'm going to put an X because we might want to change the Y. So, although I guess we could access the same property. Well, okay. For the future, I'm going to put this in just in case we change the Y value. So I'm going to search this, go back up to the top here, and just change that property name as well. You don't have to do this, but in case we add, like, for every row that you complete, the bugs start moving down faster, or whatever. For every column, add some more variation to the game. Okay, I think that's all we need. So let's go ahead and save that. Hey, there we go. So now we have bugs moving off to the right, but they don't have their world bound set. So they just slide off the screen, right? So now, while we're still inside of this else statement, we want to add, we want to assign the leftmost bug a value of sorted enemies 0, and the rightmost bug a value of sorted enemies with an array of sorted enemies.length -1. Okay, so that's confusing because we don't know what this function does. This is what was set at the top, and it's what had that sort method attached to it. So we'll take a look at that in a second. This is going to be after the for each iterator inside of here. And we'll type this out first and then break it down. So game state dot leftmost bug. This is going to have a value of sorted enemies accessing the index of 0. And then the second line is going to be game state dot rightmost bug equal to sorted enemies. And in this array, we're going to have sorted enemies with accessing the length property -1. All right, so let's try to investigate this, try to be a detective here, and before we even know what this is doing. So the logic of this is that we're creating a new property within the game state object. So we're creating the property of leftmost bug and rightmost bug. The leftmost bug one is calling a function. We don't know what it does yet, but it's calling a function. That function must access an array. And the way we can understand that is that the only array that we've really created so far is the enemies array. CodeCademy is refreshing, so give me a second here to get back to this. So the sorted enemies becomes an array, and then we're accessing the 0 index of that array. So basically saying the first bug that was created, right? Or in this case, we can see from the logic of it, it wants to be the bugs column that appears first, right? The ones that are only 50 pixels from the left edge. Same thing with the rightmost bug, except within the array here, or the index that it's accessing, it's taking the length of the array, so that'll come up with some number of like, what do we have, like 4 by 9, so it'll come up with 36. 36 minus 1, so that equals, that'll come up with 35, and then that will access the index of 35, which is the last bug, right? Because if we just put in a number like 36, that wouldn't work because arrays are 0 indexed. So even though we have 36 bugs, the last bug is actually at 35. If we put in 35, then that would work for the first time, but after we destroy those bugs, it would no longer have a 35th value, and then it would just return undefined, and we would lose, or the game would completely freeze. So we don't want that either. We want it to adjust based off of how long the array actually is, which is really clever. It's like, okay, you're taking an array, you're saying that array is changing, so let's just take the length of that and do an equation with it, just subtract it by 1. That gives us the rightmost bug. Now, you might be asking, and I was too before I learned about this, how does it know that that's the rightmost bug? We populated them randomly, so it could be that, well, bug 35 is like the one in the middle, or, you know, the one on the left edge. So, looking back at this function, we'll be able to discover what's going on there. So within this sorted enemies function, we have a variable established, and it's set to the array of the enemies. Then we have this sort method that we've never seen before. Sort AB with a function A, X property of A, and minus the X property of B. What does that mean? Well, I'll tell you. So sort, and actually the documentation on this on the Mozilla site for JavaScript will explain it better than I will at the moment, and you'll be able to see a visual representation of this. But basically, the sort handles an array, and then it does some operation that returns a value negative or positive or equal to 0. It's looking for either a negative number, a positive number, or a 0 number. If that equation results in a positive number, it will, let me get this straight. So the positive one will flip B in front. So it takes two values. It takes the first index and the second index, does some operation with it. If it equals a positive value, then it flips the second value to the first place. So B would become the place of A, right? And then it moves on, and then it says, okay, now the next value, the second index and the third index, and then it compares those. If it's a positive value, then it flips the third to the second place, and etc. If that's a negative value, then it keeps the same order, or no, it doesn't keep the same order, or does it? Yeah, I guess it does, because it's saying that A is then, well, not to muddy the waters, if it ends up with a negative value within the equation, then it will just keep the same order in this case, with just two variables like that. If it's 0, then it won't do anything to it either. So in this case, it would be the same whether we got a 0 or a negative, but if it's positive, it would then flip. So all of that to say that the way that this is handling within our game, is it looks at the bug, the first bug that we created, wherever that is, and says, is that X value, when you subtract the second bug's X value from the first bug's X value, is that a positive number? If it's positive, that means that the first bug's X value is larger than the second bug's X value. And therefore, we want the second bug to be numbered before the first one, meaning that we want to know that these are sorted by the x values. So x value of 0 should come first, and x value of 550 or whatever it was, 450 should come last. So if this ends up with a positive number, we know that those values need to be flipped, because there's a bug in a lower index that's at a higher x value. So if that didn't make any sense, I'm sorry, but hopefully it did. Like I said, there's documentation on this. And yeah, but what this is doing is it's sorting them by x values. So when we have that all set up, then down here, when we access that function, now that it's sorted, the 0 index will be the leftmost bug. And then if you have ones that are like stacked on top of each other, that won't matter so much, because all we need to know is the x value of any of them. So if it comes out equal, where like all of the bugs in the first column have the same x value, that's great, because that means that all of them will be 1, 2, 3, and 4, either randomly set or set like this, where it's just top to bottom. The sort method doesn't really know what to do with those. It just keeps them in the same order, but that whole column will be the same x value. So that'll be 1 through 4. If we get rid of a couple bugs, then everything in that column will still be the first couple of indices. So that's what that one is doing. And then down here, same difference, but the sorted enemies establishes the array, and then it says whatever the length is minus 1, which would mean the very last index, which is going to be the rightmost bug. It's a very long explanation to that, but that is how we are able to establish the left and the right in our group. Okay, so then under GameState.rightMostBug, add an if statement that checks if GameState.leftMostBug, the x value of that, is less than 10 or greater than 400. Or if the rightmost bug x value is greater than 440. All right, so let's write this out. So if GameState.leftMostBug, if that x value is less than or equal to, or no, if it's just less than 10, and then or, so we need our two pipes in there, or if GameState, oh, let me spell that correctly, GameState.rightMostBug, that x value is greater than 440. Oh, and I noticed that this right here needs to be flipped around, right? So less than 10 needs to be the less than there, greater than 440. And that'll check to see if the left column has reached the border, or if the right column has reached the other border, right? And we set it to a value of 10 because there's 10 pixels before the bug's origin. So if we just set that to 0, then the bug would, like we saw at the beginning, the bug would move over past the frame, and then it would hit its origin point at its center and then move away. And then same thing with the right side, we're setting it to 440 instead of 450, which is the literal end of the frame, because half of the bug's width is 10. So same thing. So we want the legs we don't want any part of the bug to disappear. We just want it to just barely touch the edge and then move to the other side. And this is how to do that. So inside of the if statement from the previous step, multiply the velocity by -1 and save that value to the velocity. Okay, let's do that. So GameState.enemy velocity multiplied by -1. Then we want to iterate through the array and increase the y property of each by 10, saving the new values. And this is what will give it that Space Invaders look, and how they pop down to the next line, right? So iterate through GameState.enemies.getChildren, and you guessed it, we're going to do a for each. We're going to string a for each method on that. Just put in like bug as the element there, and then bug.y plus equals 10. And let's see if that works. Whoa! Okay, so so they reach the right side and then they shoot downward. Woo! Okay. So the enemy, oh right, because the velocity is not -1. The velocity is like, yeah, that doesn't exist because we changed it to x. This needs to be enemy velocity x times -1. They still do that, but that's weird that it didn't throw like a reference error because, let's see, times -1, GameState.enemy velocity, bug, the bug's y property for, now the bugs will move downward after the leftmost bug or the rightmost bug collides with the game's borders. So if the game, let me make sure I got everything before that right with the GameState.leftmost bug, x is less than 10, or GameState.rightmost bug is greater than 440. Yeah, so that's firing. That's so we know that it's setting the column, or it's identifying the column, and then it's also identifying when they reach the edge. GameState.enemies for each bug. Bug, okay, so yeah, so the velocity is working. We checked that before. It's just literally when they hit it. So y is plus 10, but it's like being added infinitely, I think. Get children for each. Get children for each. Might check the hint on this one. I'm not sure. I'm not coming up with any ideas of how to resolve that. So now the bugs will move downward after the leftmost bug or the rightmost bug collides with the game's borders. Well, it collides with the borders, that's for sure. Or at least the right border. Oh, we need to save the new values. So we need to save this to what? So we iterate through each one and change its y value, but then we need to save that so it doesn't do it every frame. What do we save that to? Save that value to GameState.enemy velocity. Oh, I see. I see. Okay, so this needs to be saved as -1. GameState.enemy velocity x equals that same velocity, but times -1. Let's see what that does. Okay, there we go. Yeah, okay. Cool. So now they're shifting down like that. Sweet. Now they will eventually like go off the screen. So we could set up a collider where like the bugs touch the bottom. or maybe like once they touch the bottom, then they'll start moving up again. I like the second option better, because then you could just like literally just wait until they reach the bottom, and then in the first option, you could just wait and then win. But right now they'll just go off screen and nothing will happen. But cool, okay. So let's see here. So now since the bugs can move downward, they might eventually hit Cody, which means the game is over. So we need to add a collider between enemies and player that has a callback function to end the game. Your callback should set the game state active to false, set the velocity to 1, and pause the game's physics, and then tell the players that the game is over. So everything that we did before, when the enemies equal 0, or when the this was just, I think it was all this, except we would say game over instead. So it would be the text from before. We need to add this into our create function and not the update, so above this. So this dot physics dot add dot collider, game state dot enemies, and game state dot player. And this will have two parameters, bug and Cody. I don't know that we really need. Yeah, I don't think we need to have any parameters here. It's just going to be empty parameters there. Whoa, it's like just the edge of the line there. Okay. So GameState.active equals false. Let's stop the game. Let's pause the physics. We also want to set the velocity, the enemy velocity, to 1. Enemy velocity, in my case I put in x, that equals 1. And then we need the game over text from the pellets collider. All right. So that should be enough for the bug collider, and now we just need to play the game to the point that we can touch a bug. See if that works. So let Cody wait until he can touch a bug. Alright, gonna try to touch a bug without touching a pellet. Here we go. Yep, there we go. Okay, so it stops, but it freezes. And doesn't pop up with the text either. Claire, did I not save this before? Or is this just... is the syntax off somewhere? Oh, I think it might be... let me just make this an arrow function instead. It doesn't really matter, but I just want to see it more concisely. Okay, so GameState.enemies, GameState.player. So the collider is working, but what happens when the game state equals false? It should be the same as what we had up above. Physics pause. The velocity is set to 1. Physics pause. It's not rendering the text though. Weird. Let's try that again. Let's try that again. 15. Yeah, I literally just copied those lines down. GameState.player. This is correct because this is just going to be... Okay, let me see if I can touch a bug. Okay, that time it worked. Sweet, okay. That was working. It was just a bug. How about that? Debugging our code, eh? That should be the name of the screen, of the stream. Debugging our code. Which, that also gives me an idea. So what if we... So you know how the, all the sprites, how they are created, we just name, access the preload image. So instead of bug, where was it? So once Cody... Right here. When Cody shoots his repellent, let's not make it the repellent. Let's make it a bug. Yes. And it's that easy. And it makes the game way easier too. Now that when the giant bugs collide with the little ones, we win. Cool. We could even make that, we could change that to be like Cody himself. He shoots out other versions of himself. Whoops. Let's go back. Yes. Yeah, and the scale is way off because they started out with like with a much larger scale. Go ahead and set that back to bug repellent. Okay, so let's make sure that our game works properly for the other wind or game over conditions. So go back to the collider with a game state player and pellet. Inside of the callback, set the velocity to 1. Oh yeah, so we're gonna have to set the velocity back to 1 for each time, so they're always starting like from the same point. Also, this is interesting where they have like when it's a game over, all of the pellets populate it all at the same time. Doesn't matter, it's just that's what it looks like at the end, which is interesting. But yeah, so game state.player and pellet. Right here, on line 83 was our collider for that. So we need to set our velocity to 1 here as well. So enemy velocity of 1. But we don't, it's not a function. I was like, okay, let's try that again. Game state dot player is equal to 1. No. Enemy velocity. I was thinking about 3 other things. Okay, enemy velocity equals 1. That way the bugs will reset their speed every time, anytime the game ends, whether it's through a pellet, through you winning, or touching a bug. So then inside of the update, we also need to add this. In the if statement that checks to see if the number of enemies equals 0, we set it to 1. Okay, so right here, about number of enemies equals 0. After the physics is paused, we need to set the velocity to 1. Okay, let's try that again. Click to restart. Good, seems to be working just fine. Just fine, okay. All right, fantastic job on recreating an arcade classic. Okay, so at this point, you've done it. You have completed the base of what we were building today. There are a few more things. If you want to stick around and see the more complicated bits, some of them are more complicated. But good job. If you followed along, good job. Yeah, that is a Space Invaders, not replica, but an homage, I suppose. But okay, so now if you want to challenge yourself further, add in a high score system. We did that with the other game yesterday, the falling bug one. In this case, since our score isn't like based off of points, I mean, it's not that hard to complete the whole thing, and adding in a high score might not last long. You get to 24 and that's it. The high score has a cap, so basically you know that once you've completed the game, that's as high as you can get, and there's no more. We're not adding extra levels for this one, so I'll go ahead and skip that step. If you want to see how to add a high score, we've done that at least 3 times before in other videos. But very simply, you would populate it just the same as you would a score. You would set it as the game state object or within the game state object, and then you wouldn't reset it. So like this, the score text resets once the game restarts, because what happens is that, actually hold on, where does that reset? So we want to see where this the bugs left equals to the total number of enemies. Oh, it's just whenever the scene starts. So whenever the scene starts, they put in that just manually as 24. If you wanted to add more bugs, you could also put this in where, wait a second, we don't have 24 bugs, do we? I thought we had more than that, because we have more. We have 4 by 8. 4 by 8. That's 32. Wait a second. What happens when we go? That's so weird. Yeah, they set it to 24, but we have 32 bugs. Okay. Well, I found an issue. This needs to be set to 32 manually, or easier than that, if we want to change the number of bugs we have, we just need to copy what we had down here, that template literal, to tell us to tell the game what to display. So let's copy that and put that back in the initial point where it talks about the score. It's right here. But this also needs to be like within interpolation, like this. So bugs left, and then instead of a quotation mark, we need a back tick at the end of that. There we go. Now when we started, it just breaks because I did something wrong. Bugs left, total enemies. Let me get rid of these for a second. Nope, still broken. I wonder, since the enemies group is not created yet, yeah, we might have to add this later. So the score text needs to populate after the enemies group is declared. I think that might resolve it. Let's see if it does. Yeah. So that was just trying to access something that hadn't been created yet. Okay, so now we have our proper bug number. If we wanted to change the number of bugs, all we do is we go to our for loops that was creating the enemy array, and we change the number of this. So if we wanted to be more difficult, add like 12. Add 12. Let's see what that looks like. Whoa! Yeah, so that breaks because the increment between them is too large. So let's change these values. Instead of 50, let's say 5, right? Let's say 5. Whoa! Okay, let's say 15. They're still falling out of the sky. Let's say 15. There you go. Look at that. All right, let's not do 15. Let's do 35. 35. There we go. And so if you want to make the difficulty, if you want to increase the difficulty, you can do it like that. And when you do, since our reference is determined by the array for the bugs left at the bottom of the screen, that will always adjust based off of how many bugs there are. And with that, then you would be able to add levels. So basically, with every level, you would increase the number of bugs. So basically, have this set to, instead of like a static number, have it set to level +9. And this is kind of like what we saw. It's not going to do anything because that doesn't exist yet. The variable doesn't exist. But you'd set level to like 1. Level +9 would populate 10 bugs on there. I'll go ahead and do that since that doesn't sound too hard. And then we'll put in a stopping condition at the end for like, 5 levels or something. This is not part of the challenges here, but we're going to add it in. I always like adding a few levels to the games. Oh, and before we do that, actually, let us randomize the bug sprites. So we're going to create a bug collection by going to game state. We're going to add in a new property called bug collection. This is going to be set to an array. The array will then have our three bug images. So we can I think we can just access them through, yeah. It doesn't matter if these actually have like a reference that's connected, because once we use them in the function, then it will. And I'll show you that in a second. So bug 1, we'll do another string of bug 2, and a third one for bug 3. Okay. Then this bug collection is what we want to reference later in our functions. So down when we're creating the enemies back in the for loop, instead of doing bug 1, we're going to randomize this value. So you want to do a math floor math random. This is going to be multiplied by 3. And this, that whole, when we create a random number, that needs to be contained within an array. So we need an array. This array is going to be the bug collection array, right? So we need to access GameState.enemies, or sorry, GameState.bugCollection, and then a random index of that bug collection array. So now when we populate them, they'll come up with the green and red bugs. There we go. Cool, cool. All right, so now let's let's make a level system. We're not going to add in sound effects. We will try to increase the speed as the number of the bugs decreases. And different point values for different bugs. That one we did with the falling bugs one. Again, like I would just change the score system entirely. Instead of saying how many bugs are left, I would add in like a new score and then a high score. But for this one, I think I'm just going to keep it as the number of bugs left over, and then increase the speed as the number of bugs decrease. Okay, cool. But now that we're adding a level, I might want to add in a high score too. So I think we'll do both. But let's first add in our level system. So let's say we want to keep this at, let's see, how many bugs appear if we do 12? 12, quite a few. Let's see. Set that to be like 40 pixels apart for that one. Whoa, yeah, that's like really tough because they're moving down so fast. Is that even possible? Let me try to Let me try to complete this, right? Beta test the game. And this is where we would definitely want something where the bugs reach the bottom of the screen and then they start popping back upward. Yeah, that would be incredibly challenging to clear them before they reach the bottom. So let's set that back to, let's see. I think 4 rows is good. We might want, yeah, I think 4 rows is fine. We'll just adjust the number of columns for the levels. So let's start that at like, what does 6 look like? And I guess the Y value could be the same throughout, and we'll just adjust the X value. So this could be like 50 for all of them. But then see, they kind of start at their origin point at the top, so I kind of want to change that. So what if Y equals 1? Yeah, and then change this to like 20. Oh, but then their spacing is going to be different. Yeah, let's set that back to, I kind of like 35. 35 felt good there. Yeah, we'll start with that. So we'll keep our Y values the same, just keep that as 35. I added a 1 here so that they don't start like at the very edge of the frame. And then underneath 40x. So we basically want this to decrease. I think we can decrease it by 5 every time. And then they'd still be set into columns like that. Yeah, so this could be the first level. So 6 and 70, I kind of like that. If that leads us to, so let's do the math on this. So 7, right, would be 65. 8 would be 60. 9 would be 55. So let's actually set this, if we're at 6, set this to 65 to start and see how that looks. Yeah, looks good. Looks like an easy level. 15 bugs to start out with. Okay. So then now we'll say that once we establish the level property, we'll say level plus 6, right? Or level plus 5. So that when it's level 1 will equal 6. This will be a global variable that will scope up in here. Actually not a global variable, but a global property, right? So scope it within the game state object. Level is 1. Okay. Back to our for loop. We'll say game state dot level plus 5, right? And when we start the game, that should work immediately. Yeah. So now game state dot level plus 5 is equal to 6. So then we have 15 bugs in total. Oh, we only have 3 rows though. We need a 4th row, don't we? Yeah, there we go. That gets a little more complex with like the math of it there if we want to have the columns change as well. Because then we would need like an if statement within the loop. So like if level If level is greater than a certain amount, then changes this to 4. I've never done that before where I've tried to put a conditional inside of the loop parameter. I don't even know if that would work. We can try it though. So if level is greater than or less than say the first 2 levels have 3 rows, or the first 3 levels have 3 rows, and then the 4th level has 4 rows. Every level beyond that has 4. So the y value would be, oh yeah, but that's the thing. How do you say, yeah, we're gonna need another loop, huh? Because you can't just say like, oh yeah, if this level is less than 3, then put a y value of less than 3. I mean, I'll try it. Else, it gave me like, it turned the things I'm writing HTML now. I might very well be. Okay, else y value is, yeah, just have this be y val is less than 4. Or this needs to be 4, this needs to be 5. Yeah, totally broke. Man, if only that worked. If only that worked. Okay. Yeah, that gets a little more complex. All right, well, let's go back. I always like trying something on the edge of my knowledge. Let's just set that to 4. I'll have 3 lines there. Could have it be like 4 plus level. Or we could do it this way. So instead of that, let's say like column difficulty or something. Column number. Just column num. Okay. Have this equal to 1, I guess. And then we'll set up an if statement in create. Doesn't really matter where. I'm going to put it like above the for loop. So if at this point column num, which is going to be, I wonder if we could make that the same as, oh, I know what we're doing. Okay, level, right? So GameState.level. GameState.level is greater than 3, and column GameState.column column num equals 5. So now we can set this to be y value less than the column num. So GameState.column num. And set this to 4 initially. And so when that increments, then the number of columns will change after a certain level. Make sure that didn't break anything. Sweet. So far, so good. Now we actually need to tell it when to switch levels. This is going to be after the when condition. So all that is set within our for loop. Let's scroll down to the when condition. And where was that? I think it's in the update, right? The enemies, the total number of enemies equals 0. GameState.leftmost bug, sorted enemies 0, rightmost bug, sorted enemies, length of -1. Yeah, maybe after this. False. No, we need to reset it, right? So it's in our click then, yeah? and to restart the scene. We need to increment level after we win the one level, which is when number of enemies equals 0. So here, you just say level, game state.level, and then plus plus, right? That'll increment the level property. And then once the game restarts, will it reset the variable that we have? This scene restart. Yeah, that might. Let me see. See if that works. So we're gonna try to win level 1 and see if we get more bugs on the second time around. Yeah, because once we click this, yeah, if we click it, it doesn't do anything now. That's also strange. That's been on and off. That's been happening. So let's try this again. No, now the click is not working. Weird. That's very strange. Let's undo what we did there. Well, that's unfortunate. Let's make sure that's working, because then we won't have an ability to restart our game. Ah, man. Okay. Weird. Weird. It was working a second ago. Maybe we need to reset this as well. I don't know. I'm gonna keep testing it. Because once the game state is set to false, once the active state is set to false, then you should be able to just click. Unless something is freezing as it's doing that. Please? No! Okay. Well. So I also need something else here. So and game state. Oh, hold on. Game state is a global object, right? So it can be accessed by anything. Yeah. Okay. Game state dot level. So let's say we were inputting 5 levels. Game state dot level is equal to 5. All right. Then we run all of this. If not, then we just do an else if. Else if number of total enemies is equal to 0. I don't know if we have to be explicit about this and say like game state level is not equal to 5. We might also. I need another ampersand up here. But I think it should run that first and then check the next one. So else if it's equal to 0, then say level game state dot level plus plus and this dot scene dot restart. I think that's what we need to do. Of course, when we restart it, it's going to reset the score value. Yeah, that broke everything. Okay, well, let's save that. delete that. Didn't like that at all. Oh, we already have an else statement there. We need this to be a larger one, right? And say that the bugs are moving, but we need the else if to be above the else statement. So this needs to be copied and placed above the else statement there. And now it still breaks. Because we don't have enough, or we have too many of these. We have too many braces. Let's see, where's this one going? It's going to there. Else if number of total. Yeah, maybe this does need to be like explicitly stated as it does not equal to 5. It is not equal to 5. Let's try that. Not equal to. Nope. Does not help it. Maybe it's that. No. What part of it doesn't it like? Just doesn't like the else if statement entirely. Why? Why doesn't it like that? Num of total enemies. Game state level is not equal to 5. Couldn't tell you. Couldn't tell you because it's not those two lines. Is it just this? It doesn't like the. So if we get rid of the code block. Okay. So it doesn't like this. What did I spell wrong? Because I know. Oh, my number of. I need an of there. There we go. Okay, hold on. We can get back here. I just have the variable set wrong. Yeah, I was returning undefined. Okay, there we go. Now we're playing. Now we're moving. And now let's see what happens if we defeat all the enemies. So in theory, that should restart the scene, but then add 1 to the level. Yes, yeah, it worked. So then we had 18 bugs at the start of this one. And I think if we can get through... Also, now we can see if the row one is working, the column num, right? See if that one works. That variable we set before. Whoa! Well, it works up to that point. What happened? Oh, the velocity, right? We need to reset the velocity? Yeah? Or after the restart, I guess? Set it to that. I don't think we need to do that because that's already set. I think it was actually the fact that, where was it? Where was it? So if game state.level is greater than 3, we didn't even reach that point. We got to 3. That was it. Game state.level. And then this became 2, right? Oh, I know what's happening. I know what's happening. Right here. This spacing. The spacing needs to change based off of the level. So game state.level. We need to subtract that from 65. Or I guess we need to subtract it from 71 at first because that's the... hold on. If we subtract from the level, it needs to be game state.level times 5 minus 1, right? Or game state.level minus 1 times 5 because it starts out as 1. Game state.level times 5? Yeah, that's all that we need. So minus game state.level times 5. This will then be 5 at first, so then it will, if we put 70 here, it will make it 65 in the spacing, and so on. So I think that will help, because it was running into a conflict, I think, where the spacing wasn't enough for it, or something was messing up with that. So we'll try that and run it again. I don't think we need our velocity reset, because the game, not there. We do need that one. This one. After our restart, because the restart just resets it anyway. Whoa! Okay, no. No. That doesn't make sense. Minus GameState.level times 5. That should just equal 5. What happens if I get rid of this? Oh, I need more parentheses, don't I? Yeah, because that needs to happen before you multiply it by the x value. Is that gonna work? I don't know. I don't know. There we go, yeah. Order of operations here, okay. So now let's see, once we complete the level. We need some music now. We need some music and sound effects. No? Okay, there we go. So there's 5 levels to this. Once it reaches level 4, it should add a 4th line, a 4th row. Let's see if I can actually defeat this. It does get challenging if you just leave one column empty, because of the way the pellets spawn in. But we'll see if we can do it. Nope, come back. Also, we still need to code in when they reach the bottom to snap back up. Like the Y velocity to change. We'll do that at the end. Yeah, okay, so now we have four rows. And yeah, okay. And then once you get past level 5, then you actually win. Let's display our level counter. So we're going to copy this one for the score text down. Oops. And change this to level text. Within this, we want this to say level. You don't need a colon there. And then this is just going to be GameState.level. Okay, and should be all we need for that to display. Oh, but it's at the same point, so we need to move this over to the right, maybe like 300. Maybe a little bit further over, 380. Okay. Sort of working. It looks like it's like displaying maybe a couple times. So that's just the way the font's displaying. Okay. Then we need to set the level every time the level increases. So easy enough. We just scroll down to where we increment the level at the bottom here in our update. And underneath this, we're going to put in GameState.level or level text dot set text, and change this to be to just update it. So it's the same text as we had up above, but we're just updating it here. GameState.level. All right. So now when we complete a level, that should tick up to 2. We can also change the delay of the pellets that are coming down for each level. changed the difficulty a few times. CodeCademy decided to refresh itself, so we're gonna have to play level 1 again. There we go. Yeah, you can make the pellets come out, make that delay smaller based off of the level. So like the level, so started at like half a second, and then the level times 50. So 50 milliseconds, the delay will decrease by 50 milliseconds every time you increase a level. There we go, and now our level is 2. When we get hit by a pellet, what happens? Okay, it remains that way, and when we click to restart, it's still that way. So what we need to do if we get hit by a pellet is reset the level, right? Or any time the game state is false. So this scene restart, we also need to reset the game state level equals 1, which is weird because I guess it's not weird because the bugs reset based off how many bugs are populated. So if we added a score, we would also need to reset the score in that same place too. So let's see here, let's defeat the first level of bugs. Get him. There we go, and now if we get hit and we reset, then it resets back to level 1. Perfect. Okay. Okay, what else? What next? I would like to change this to be space. So I guess, yeah, but it's a little bit different here, isn't it? It's like this needs to be set to this keyboard input. All right, like down here. And so like if the game state is false, then check that. Yeah, we're gonna change it to that so that if you click space, you press space after the game is over, then you restart the game. So let's go ahead and do another if statement underneath all of this here, and say if game state.active is equal to false, then if this input, is it input or is it, it's cursors for this. So cursors dot space dot is down. We need a this scene restart, and then we also need a level reset. So level, whoops, game state dot level, there we go, is equal to 1. Okay, cool. So if we die, yeah, it breaks it. Wonder if we just need to delete our listener first, or not delete it, but comment it out for the moment. Let's comment this out. There we go. And comment it out down here. Okay, so far so good. Let's see. And nothing happens. Okay. Oh, we don't need it there. We don't need to check if it's false. We just need to have that event handler within our collider, because that's why it's stopping. So delete all that. Delete all this. And besides, I don't even know if I was putting it in the right place. Delete that. It's when a pellet hits Cody, right? The game state is false. then you populate the text, and then you say if GameState.cursors left is down. Maybe that would have worked. I used a this instead of GameState, so it probably was looking at the scene itself. Anyway, this will work too. So GameState dot cursors dot space dot is down. This, if that is down, then it will say this dot scene dot restart. I think so. And level game state dot level equals 0, or not 0 but 1. Doesn't matter, we can see if it works regardless. Nope, it does not work. Try that again. No, why? Why not? Why doesn't it like that? I don't know. I don't know why it doesn't like that. Maybe I need an else here? I'm not sure. Maybe the scene restart is not accessing the right this. Can I just add it in the event handler up here, where it's like, yeah, I don't know. Maybe you just have a conflict with that then. Conflict with the... This input on pointer up. If game state active is false, then that. This scene restart. If game state.cursors.space is down, this scene restart. Well, we might just keep it to the click then. That's a little bit more complex than I envisioned. I don't know though, like if we keep this above, if game state.active, I guess, oh, we need that to be explicitly true, because if that's not, if that's just looking at the truthy value of it, it's gonna say, yeah, it's a truthy, it exists, right? It exists, so we're gonna run this code, and if it doesn't exist, who cares? It's still, you know, or if it's false, who cares? It exists. I mean, I know that false is falsy, right? But we're gonna try. We're gonna try explicitly stating that that's true, and then adding this little bit down here, which is probably the monkey wrench. Yeah, okay, there we go. But but we need that to be if the game state is false, and now the click's not working. I don't understand. Why does the click break? What is going on? Now the click's just broken. Why? Save this. Try this again. Oh, because I commented it out. That's right. Not even paying attention to my own coding. Okay, so space is down. That works, and that helps us restart the game. However, we don't want to restart it with that. We could make it the enter button or shift, I guess. We can make that shift, but we want it to be only if game state, if game state.active equals false. Then we want to contain this within braces. Okay, so now, whoops. Yes, okay, now that's working. So move around, get hit by a pellet, and then press space to restart. Wonderful. Now we just need to add that to the text here. Instead of saying click to restart, we want to say press space to restart. And see what happens when we get hit by a pellet. Press space to restart. That needs to be tabbed over a bit. Let's make that 100. Make that 130. Looks better. Probably like 125 or something. 125. Yeah. All right, so 125 there. This is going to also change here wherever we say click to restart. So press space to restart. And down here, when we win, press space to restart. So in any condition, whether we get hit by a bug, we win, or we get hit by a pellet, we'll be able to press space to restart. Now, and then the level resets to 1 when that happens, and the game itself restarts. Okay. Then let's see about moving the bugs if they hit the bottom, if they hit the platform. Oh, yeah, that makes sense. Just have them hit the platform. If they hit the platform, add a collider and then negate their Y velocity movement. How would we do that? That's a little more complicated, huh? Because their movement is controlled by all of this, right? So it's saying that once the bugs reach the edge of the screen to move them down. So basically in here we need to string together something else. So if the x is less than 10 or it's greater than 400 and and it is above a certain threshold, which let's just say, like, I don't know how large the platform is, like 20. It's like 20 pixels above. Let's just say 25. Or yeah, 20. So let's say game state dot, all of the bugs are going to be at the same point on the same row. I'm just gonna put enemies. Game state dot enemies. I don't know if that will work. Game state dot enemies dot y is, because you could end up with a situation where you have a bug that is on the top row in both the leftmost bug and the rightmost bug. So we don't want to just say leftmost bug or rightmost bug, because then you could have bugs like underneath the platform before the top one hits. So enemies.y might work. We'll see about this. It's greater than 20. Okay. Then you do all this, right? Set it to -1. And oh, no, let's not do it like that. I'm very curious to see if that actually works, where you can like string together a whole bunch of, you can string together an or and an and. Let's see. Nope. It just breaks it. Y is enemies.y is not greater than that. Oh, maybe bug, because this is still within the for each statement, right? Or no, it's not. Enemies.get children. Get children to access the array properties. Possibly. Nope, they just continue on out. So we're gonna say, I don't know how to access that property exactly, the Y property of like the whole group. I thought it was just enemies. I thought you could just say, but that's an array, right? So I don't know how to access that. Anyway, we don't need to know here, at least. We don't need this to be here. What we do need to know is that once we want to change the Y value. For each bug Y 10, okay. Yeah, so then we run into the same problem, right? So if we say if, like, if the game state dot enemies dot y is greater than 20, then we want to contain, we want this for each thing to happen here, for each method to happen after that. Okay. This then needs to be here. Okay, so if, I don't know if that's referencing the right place, but basically saying that if the enemies are at a certain y value, then execute this. And if not, oh, but they're not above 20. This needs to be above or less than, because y is positive going down. This needs to be less than, what did we have, 500? So like 480. If it's less than 480, then you keep it going. I think that would have worked up here too. I'm just doing it in a different place so that it's a little less cluttered up top. So let's add in our else statement. This is going to be the same as here, that for each statement, except it's going to be minus equals 10 instead of plus equals 10. Cross your fingers. Okay, well, yep. So they're going up. Is y not less than 480? Y plus 10? Okay, does this exist at all? That's so strange. Okay, so no, it doesn't exist. How do we access the x values without declaring a for each method? Bug.x game state.enemy velocity x plus equals I mean, I could make it so that it's just the index of a certain bug, but that doesn't really work because it's like it needs to know what the bottom bug is. You could make it be like you need another sort function, right? You need like to say that the y values are a certain way. If the bottommost bug, oh my goodness, wait, maybe that is right. Hold on. Ordered by x coordinates. Okay, we're gonna shoot in the dark here. Constant ordered by y coordinates equals game state dot enemies dot get children dot sort. This is going to be the same a and b, but instead we're going to have y values here. So the only thing that we're really changing is just this little part here. So a of the y of a minus the b of a. Okay, so that's ordered by y coordinate. We want to return this value here. Okay, so now we have that value saved as a variable, and we can access the bottommost bug. Well, we need to set our bottommost bug. So game state, I'll just call it bottommost bug equals sorted enemies wait a second. Wait a second. This needs to be a separate function, right? Yeah, this needs to be a separate function. You might be able to do it in one. I mean, I'm sure you can, but we're going to sort it by y. Sorted enemies y. Okay. So let's take this, right? Get rid of that x coordinate there and just return that. So we're creating a helper function like the sorted enemies here for the y coordinates. So back to our, where were we? Set y coordinates to that. Yeah, back down here. Rightmost bug, bottommost bug. Okay. Sorted enemies y. That, and then of 0. No, we don't want of 0. We want the last one. Because since the y goes from 0 to 550 at the bottom, we want the bottommost bug. We want to know when he touches the platform. So array sorted enemies y. We're going to do what they did up there and access the length property of that. Length minus 1. So that it will always be the last bug in the line. The bottom bug. Whoops. Okay. Now, if GameState.bottommost bug if that y value, which I think, let's see, yeah, if its y value is greater than, or less than, sorry, less than 480, then you add values to it. But the problem is when that happens, it's just going to be like, okay, well, it happens once and then it keeps trying to go back down. Ugh. Okay. Well, it's good that we created that though, because I think that if we string this along, we say if the game state, blah, 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 x values are this way, y values are less than 480, do this. Else if the same or statement, but y values are greater than 480, do this. But that would still end up with the same thing. Man, you just need to set the velocity. Because it's just a switch, right? It doesn't need to happen every frame or every second. It's just a switch to say change direction. Wow, that's interesting. It seems so simple, but I don't know how to do that. So once they reach that point, then reverse the downward motion. Whoops. Just knocked over something. Reverse the downward motion. Bottommost bug. Dot y. Y, oh y. All right, well, we'll run this. We'll play it, see how it goes. Let the bugs reach the bottom and see them kind of fidget at the bottom. It's like when bottommost bug reaches 480. Right. If it's greater than or equal to 480, run a different code. But I don't know. I don't know how to do that. Oh no. Reset. Reset. Three bugs left. 3 bugs left. gonna take them a long time to get down. I'm just gonna get rid of these guys. Come here, you bug. Come here. There you go. Get rid of all the middle ones. Leave the edges. Oh, come on, Cody. You can do it. There you go. All right, we'll let them do their thing. Well, the bottommost bug thing was kind of clever, right? That was cool. It was cool to see that. We'll see if it works in a second. We could have it just be that you lose when it gets to the bottom too. Oh no, it's not working. Oh wait, there it is. And now it's gonna go back down and then just go back, yeah. Yeah. Okay. How do we do that? It seems like such a simple problem, but I don't know how to do it with a group of things. And the way that we have it set here too, where it's like each time this code runs, then they I don't know. I think I would have to think about that for a while, because it's like, okay, so this switch turns off, right? This switch turns off. Sounds like a variable, yeah? So I'm thinking of adding like a variable within an if statement underneath here. Say that like if bottommost bug reaches 450, then like switch, or let's not say switch because that's actually a keyword. Like let flip equal bug.y times -1. Yeah. Or something, right? Just have it be let flip equal -1. I don't know. I don't know. Because that would be the same though. Because it would just happen once. Yeah, this was the problem that I was thinking about when I made it the first time too, and I didn't come to a solution. So it's like bug y times -1 . But we wouldn't want that, because then that would be like -400. What if we made this just a binary thing? So 0 or 1. Say flip equals 1, or flip equals 0 at first, right? Once it reaches 450, we'd say flip equals 1. Okay. So we need to contain this within another if, right? But we need to establish the variable up here first. So within this portion, let flip equal 0. If flip is equal to 0. Oh, not O, 0. There we go. Then we contain everything within this block, these blocks here. Okay. So if flip equals 0, then all this happens, yada, yada, yada. Okay. We already know that it's above, or if it's under 450, else flip equals 0. Okay. Did that get rid of something? No, because the x velocity is still flipped as well. Or flip equals 1, right? So this has conditional scope, it has function scope, and then we're just setting it equal to 1 here. Then I think that should break it. I mean, it might actually break it where it doesn't run. But this else statement is contained within this conditional here. So we need to back up to this point. So that's where that one is. Else if flip, and flip will never equal anything other than 1 or 0, so we can just make this an else statement. Else, all of this code will be the same, except I think that's, oh yeah, we need that extra bit there too for that, and then we'll need one at the end, like so, I think. No, we won't need that one at the end. I'm just seeing what to copy now. This one, so we'll copy everything down like this. -1 for the x is still fine. The only thing that we're changing is this right here. And this is not going to be... if y is greater than, say, 25. What did we have set for the beginning y in the for loop? Up here. The beginning y was 35. Okay, so 35 for this one. So if it's greater than 35, this will keep happening. Else flip will be 0. And then if flip is 0, then it will go back through and say that, well, if the enemies are not equal to 0, we're going to go through all this and say, oh, but flip, so this needs to be a global variable then. which is fine. We'll just make it a global variable. So global variable, it's accessing global variable every time the enemies is greater than 0. Saying that if that global variable is 0, all of this will run. It'll run like you see now, except once it reaches the bottom, once it reaches anything below 450, then that global variable is flipping to 1, and then we have, looks like we have way too many braces here. Hold on. If that, if this, else if, there we go. Yeah, no, that's correct. So then else here, and we have all of these set to where then it checks the x value, and then it checks the y value. If the y value is less than 35, less than or equal to 35, then it will flip the global variable back to 0. And we can go ahead and make this like either the game state. We'll just keep it simple and well, you know what? We'll make sure it's possible to do this as well. So we're gonna say flip is 0, and we'll have to change like the game state down below, and just say, and make sure that we have a comma here. There we go. And make sure that the game state is referenced properly here. So game state.flip equals 1, and game state.flip equals 0. State.flip equals 0. Let's see. Ah, come on. Okay, something along the way broke. Don't know what, don't know where. It looks like something is returning as undefined. When we get absolutely nothing, meaning no background at all, it means there's a reference error, meaning syntax, or I spelled something wrong. In this case, it could still be a spelling error, but yeah. At least we don't have a reference error. Okay. I don't know where to start with this. Let's count our braces. 2. Where's the second one? It's up there. That shouldn't be right. Might need another one here, I think. Or, oh, okay, never mind. We do need this here. For this is the, that's the if one, yeah. Else statement of that. Else if this is true, then the cursors is down, blah, blah, blah. This is that. This is all happening if the game state active is true. But this one should link back up with that. Yeah. Okay. Game state.active is true. This one should link up with the else statement, right? Underneath this if, which ends there. This one ends here, yep. That one ends there, this one ends here, that one ends there. All looks pretty good. That one ends there. This one's here, that's there, that's there. X of 1, flip of 0. Oh, right. Yeah. These need to be game states.flip. Yes. Okay, cool. It's working. All right. Now let's see if we can get to the point where we get to the next level. And that's not what we're testing out. We're testing out to see if the bugs reach the bottom. But we'll complete the first level. Why not? Okay, cool. And all that's working. We got the levels going. More bugs are popping in. All right, and now we just wait. We wait until they reach the bottom, see what happens. See if they start incrementing up. And then we can test out what happens. I think, so the click is working for when you die, but not when you win. You basically have to restart the game if you win. I'm not sure why, because the game state active is always false, but I don't know. Anyway, let's see if the bugs, once they reach the bottom, increment back up. And that was, yeah, this has been going to be really cool if it works, because that was done through finding out what the bottommost bug was, and then adding a check to that, and then adding a global variable to say that we want the behavior to change. No, okay, there, okay, yeah. So they do stay at the bottom for one tick, but then they come back up. Cool. Maybe like 455, because they're starting at 35, right? So maybe, yeah, they probably just like stayed at the bottom for a moment because of that. Make sure not to kill the last one in the row there. There we go. Or the last one, yeah. The rightmost bug. I like how you can see a little bit of the translation, like, as it might just be an illusion, but it looks like the pellets are, I guess they're not really moving sideways. Some of them look like they have a little bit of a curve when they pop out of the bug. But I think it's just because the bug is moving and there is a parabola being drawn in my mind. All right, now we wait. I'm going to go ahead and check this off. I think we have sufficiently tackled this thing. You could add sound effects in. We saw how to do that a while ago. Just like this.add.sound something or other. Super easy, just like adding in a sprite. And then having it play when you collide with something or something else collides with it. And let's see. Hey, it worked. Oh, wait. Went too far. Oh, no. Oh, no. No. They're escaping. They're escaping. Are they just... Oh, weird. Oh, because I changed... Wait, what did I change? I changed it to 455? What did we have before? 450? It can't be that much of a difference. Really? Can't be that much lower. Weird. Let's set that to like literally 45. Oh, now they're going too high too. Oh, because it's going to set it to the bottommost bug, right? Oh, we have to set it to the topmost bug too. No. That's okay. We'll do that. Just doing some bug testing. That's what we're doing. Okay, so instead of... Yeah, just change that back to 450. I'm not sure. Oh, that behavior was very strange. If 450 was like at the platform, then anything below that... For some reason, it was going way below that. Unless the bottommost bug thing wasn't working. Oh no. No! Oh, now it's going to be much tougher. But we'll add in a topmost bug too, so that we can see if like when they hit the top of the screen. Run, Cody, run. This also goes a lot slower if you don't, yeah, I'm just gonna go here. Press space to restart. Do this again. There we go. That should be pretty good. You should be safe right there. Okay. Last thing I was, what? Oh man, it went way over. Try that again. Hopefully he'll be safe. Yeah, last thing I was curious about was when this happens. So the game state level is 5. And the game state.active is false when we reset the game, essentially. Press space to restart. So where we had the input of space, where was that? Was that up here? We changed that. Let me search for the space. Space is down, yeah. If game state.active space is down, then you restart. So we'd want to check to see if that works when you win too. All right, here we go. Okay, so that is working. That's working with the bottommost bug. Now we will make a topmost bug. So this is up in the sorted, like we were working on before. And then topmost bug is just going to be, yeah, just the first in the index, right? That's going to be the lowest value there. So we want to declare another property, game state.topmost. Topmost bug equals sorted enemies y and then index of 0. That's an easy one. And then we just change this one to topmost bug. If topmost bug is greater than 35 or less than 35. What was I changing? Wait, what was I changing? Yeah, if the topmost bug is greater than 35, then you do... I think that will work. Let me test it. Because it's going to flip at the very end, but I think that should be fine. Because it'll check that the bottom bug reaches the bottom point, and then start looking at the topmost bug. Should be fine. Oh, gotta lead my shot a bit better here. Lead the shot. There we go. Okay. Well, we put into practice what we learned from last week, and yeah, learned a little bit more. Learned about the sort method. And how to populate items based off of keyboard input, the space bar. And have negative gravity, right? Negative gravity. All right, let's see. Let's see it happen. Let's see them reach the bottom. After this line, they should be moving up. Okay, good. And now? Good. They're moving like way further though. That's weird. It looks like they're moving like way further over, but I guess that's normal. Just because they're closer, I think. But now, once the topmost bug reaches all the way to the top, 35 or less, then it should come back down. And then we will have a proper Space Invaders. Bug Invaders. Auto, okay. Cool. Just checking over everything else. Looking good. Yeah, I'd like to know a little bit more about the difference between that input, right, the phaser input keyboard just down versus the game state.cursors is down. I guess it would be like if you did it the other way, as you hold it, did they start going back down? Right here? Yes. Okay, cool. So they spend one time, I could probably adjust it where they never do that, but they spend like one cycle at the point of turning, and then they start coming back down. I guess that's fine. It looks fine. Cool. So we have our Space Invaders game. But yeah, so with this, like, if we had the spacebar set to a cursors is down, I mean, I don't know. I guess you would have it run just the same, right? Well, let's see. Let's test that. So one last thing we'll do here is we're going to comment out our space here. And then we're going to copy this part of it up in here. We're going to add an else if game states dot cursors dot space dot is down, and then copy in our create bug repellent thing generator, our bug repellent generator. Yeah, see, it does it. That's what I thought. Look at that. Look at that. Woo! Wait. So much easier, yes. So that's the difference. That's the difference between just and because it's strung along with, like, it's in the same conditional as the movement, you have to only press space and it will do, like, once you set so once you press an arrow key and you move Cody, if you're holding down space, he'll keep moving and you don't have to press anything. Anyway, so that's the difference. If you do a cursor spaces down, that means you can hold it down and be absolutely broken with the game. But I'm going to go ahead and use this so that we can check to see if our win condition works. Just absolutely destroying. Yep, and back to, oh, it did work, but I was pressing it so much that, yeah, it automatically switched over. But I did see it for a split second, just said you win. Sweet. So you could program this in as a cheat code or something, right? Cheat code accesses the other way to use the space input. But we'll turn it back. Just like that. Uncomment this, and now we're back to normal Cody. Normal pellets. Cool. Well, that is our Bug Invaders game. I hope you all enjoyed it. Next time, we will be jumping into a thing called class, JavaScript class. Not in the sense of a lecture, but in the sense of building out data structures. Say, like, if you wanted to create like a veterinary library, you would have a class called animal and then a subclass called dog. It's basically creating like a directory of different items that can inherit other things. So we'll be talking a lot about inheritance next time. But anyway, hope you all have a good day. Thank you for tuning in, and live long and prosper, everyone. Peace.